Good evening everyone. Good evening. Can you hear me? Almost I took half an hour break. Yes. Welcome to my class. I know everyone you are waiting. Can you hear me? Yes. Yes. It will take at least 1 minute to display whatever it is coming. Yes. Good evening everyone. Shall we start the class? Okay. This also like a basic only. First and second class thermodynamics basics we will study, because someone we don't know about the basic only properly. Okay, then next class I will explain thermodynamic properties and also laws. That one is important. Then heat engine, one more, at least 2 more hour is required to complete this thermodynamics. Then later I am planning tomorrow we will discuss the MCQ questions. Okay. Next, in this class, we will study about basic concept of thermodynamics. What is meant by thermodynamic system, thermodynamic processes, and also thermodynamic properties. Very important. Those who don't know the concept properly, you will come to know. I will explain in detail. Then it will help for you, because I don't know how much we in detail we studied in second PUC. That's why let us study in detail. Then first, what is meant by thermodynamics? Thermodynamics deals with the concept of heat, temperature, and the interconversion of heat and other forms of energy. What is mean by the word? What is the meaning of thermodynamics? Thermodynamics is nothing but that deals with the concept of heat and temperature, and also interconversion of heat and other forms of energy. I know energy you can't create, you can't even destroy, you can convert the energy from one form to another form. This one, no, that one only we will consider as conservation of energy. Then here thermodynamics, I told no, we are having the laws, the 4 laws of thermodynamics. What it will explain? It will explain the behavior of these quantities, provide a quantitative description. In the thermodynamics, we are having the 4 laws. That 4 laws, it will tell the behavior of how the energy, I told energy is the transformation of, you can convert from one form to another form. Then this laws, they will explain in detail how the conversion of energy, how it will takes place, and what are the quantities it will affect the change in the energy. Everything we will discuss in detail later next class. Okay. Then William Thomson in 1749 coined the term thermodynamics. Then who given the term thermodynamics? What is the scientist name also you have to remember, in which year also you have to remember. HSTR is mainly based on MCQ questions now. Then they will how, which type of questions they will ask, we don't know. Maybe they will include even the scientist name, discovery year, everything they may include. That's why we don't want to lose our marks. We will almost I included everything. Okay. Then what is the definition of thermodynamics? Thermodynamics in physics is a branch that deals with the heat, work, temperature and their relation to energy, radiation and also physical properties of matter. Mainly, what is the definition of proper meaning of thermodynamics means? That is a branch of physics that deals with the heat, work, temperature, then how they will be related with energy, radiation, and physical properties of matter. Physical properties of matter means, what is mean by physical property? Means external appearance like boiling point, melting point, whether the matter is solid, liquid or gaseous state, then what is the appearance of the matter, whether it is amorphous, crystalline. External appearance we will consider as a physical properties. Okay, chemical properties means, if you mixed that in chemistry you will study in detail. Chemical properties means if you mixed any two substance, then what is the changes they will happen in the chemical, that is chemical properties. But here in thermodynamics we will study only the physical properties, means only the external appearance. Only here physical property means only the orientation of particles it will takes place. Orientation or arrangement of particles it will takes place. The particles you can't create, you can't destroy, but only the orientation or arrangement of particles it will be takes place. That one only physical properties of matter. That is the meaning of that word. Then next one, don't feel it is the theory part, but this one is very important. That's why I don't want to lose any single point related to thermodynamics. To be specific, it explains how thermal energy is converted to other form of energy. Thermal energy, the energy that is it is created by when you rise the temperature. Okay, then how you can convert thermal energy to other forms of energy. Then when you convert from one form to another form, how the matter is affected by this process. See here, I am having any solid. When I provide the temperature, consider ice cube. If you provide a little temperature also, it will be converted into a liquid, correct? No, then here the thermal energy of this object is increased, otherwise this quantity is increased. Then here thermal energy is converted and from one form to another form. Here this one is in the solid form. When you increase the thermal energy, then it will come to in the liquid format. Then how matter is affected by this process? What is mean by a matter? Matter is nothing but anything which has volume, anything which has mass and occupy space, that one we will consider as a matter, correct? No, in solid, what is the arrangement of particles? All the particles, they will be very close to each other, correct? No, there is no small gap between the particles. Okay, there is no gap between the almost there is no gap between the particles in solid. This one we can consider as the arrangement of matter. Matter, once again I will explain, which has mass and also which it will occupy the space. That is very basic, you know that one. Adiba, already 1 hour class over, you are joining now. Okay, then this one we will consider as a solid. Then liquid, compared to solid, liquid, you can see the gap between the particles. Here this arrangement of particles we will consider how the matter it will get affected when you increase the thermal energy. Simple, very basic example, consider this one. When you increase the temperature, otherwise when you increase the thermal energy, then you can observe there will be a change in state of the object. Before it was in solid state. When you increase the temperature or thermal energy, later it will become a liquid. Okay, then thermal energy is the energy that comes from heat. Yes, if you provide the heat only, thermal energy you can increase. This heat is generated by the movement of tiny particles within an object, and the faster these particles move, the more is generated. Already I told when I am explaining a temperature, then here when you increase the temperature, what will happen in a particular object? All the particles, they will start moving within the space only, they will start moving fastly. In that case, the kinetic energy increases and also heat increases. All the words same. and also temperature also increases. That one only they are telling. This heat is generated by the movement of tiny particles with an object. The faster these particles move, faster the particles means the kinetic energy it will be increases. Then what will happen? Kinetic energy increases means heat increases. Heat increases is nothing but temperature increases. Okay. Then next one, thermodynamic is not concerned about how at what rate this energy transformation are carried out. It based on the initial and final states undergoing the change. What is mean by thermodynamics? Mainly what we will study in thermodynamics, we will not consider the quantity of energy transfer. We not bothered about the quantity. Okay, whether the quantity is less or more, but which are the changes it will happen. That changes is very important. How it will be changes from initial state to final state. What I explained, ice is converted into a liquid. In this example you can observe, before the state is solid, after the conversion it will become a liquid state. The state is important. Sorry, listen here. Then next one, it should also be noticed that thermodynamics is a macroscopic science. You can observe a macroscopic changes in thermodynamics. This means that it deals with bulk system, does not deals with the molecular constitution of matter. What is meant by bulk system means if you consider anything, any object, that change in the full object we will consider any object. What are the changes it will happen in full object we will consider, that is altogether we will call it as a bulk. We will not consider only the part of the object, what is the changes it will happen, only part we will not consider. Therefore thermodynamics, that is a macroscopic means very big one. In that one we will consider the bulk system, not the constitution of matter. Okay Hadima, no problem. Today only make a free time and see the recorded class, because this is the second class of thermodynamics that I explained only heat and temperature, very basic one. If you have the doubt, see the recorded class, sorry, listen the recorded class. Next one, very important one. Thermodynamics means mainly you have to remember what is meant by system, surrounding and also system boundary. These three things is very important. Then let us study in detail what is meant by a system, surrounding and also system boundary. System boundary, a boundary is, the name itself is indicating that is a boundary. Okay, it is a closed surface. This is the system boundary. This arrow mark it will indicate to this boundary, we will call it as a system boundary. Is a closed surface surrounding a system through which energy and mass may be enter or leave the system. With the help of this boundary only, energy it may enter, energy or mass it may enter into the system, it may leave into the system. Imaginary boundary. Okay, then through this one, energy or mass it may enter, it may leave. Then what is mean by surrounding? Surrounding is easy. Everything that interact with the system. In the environment we will consider. Simple words you can consider. Surrounding is nothing but when you are carrying some experiment in the lab. Surrounding inside the lab. Inside the lab what you are having? Okay. Inside the lab you are having the atmosphere, that one only we will consider as a surrounding. Okay, then what is mean by a system? A system is a region containing energy or matter that is separated from its surroundings by arbitrary imposed walls or boundaries. Simple words, what is mean by a system means the studying, otherwise what we are doing the experiment, that matter we will consider, no, we will that is a region you can consider containing energy, matter that is separated from its surrounding. Here you can observe a boundary, that boundary it will separate the system from its surrounding. Okay, consider this simple beaker. Assume inside the beaker I am having water. This water inside the beaker, it will represent a system. Then this beaker, you can see the boundary, no? This one is nothing but a boundary of that beaker. Then surrounding is nothing but the atmosphere, what you are having in that one environment, that is nothing but a surrounding. Ma'am, while sending live class link, mention the subject and topic please, so that it is easy for us to watch later. Yes, I am mentioning, no, today also you are seeing physics class thermodynamics part 2. Yes, with the link also it will come, no? With link it will not come. Now I mention physics thermodynamics part 2. I will mention each and every class. Renuka, please avoid the class before 4 o'clock, ma'am. Renuka, today I took at 4:30, not 4 o'clock. 4:30 I took the class, not 4 o'clock. Before 4 o'clock, no, I will not take the class. After 4 only. Today I took after 4:30 almost. Okay. Listen here. Understood now everyone what is meant by a system, surrounding, system, boundary. Very, very important one. Once again I will explain the same what I explained with another example. System, surrounding and also system, boundary. I took one example. I consider one example. Then thermodynamic, that is the study of effect of work, heat, energy on a system. Yes, sir, Pita. With the link, they will mention the class also, no? Okay, now onwards I will tell them, because I will create the link. They will, whatever the timings, everything they will include. Then now onwards I will inform them. Better you, with the link, you send even the subject also with topic. I will inform. Okay. Okay. Now listen here, next one. Consider this example. This is the boiling of water. Here the water, we will consider here the region under the study which is separated by a boundary, or real or imaginary. Then here work, heat, matter can go either way across the boundary. This is the boundary. You can see the round bottom flask here. This is the boundary. Through this boundary the heat and also matter, it can either enter, it can either leave also. Then here inside this round bottom flask I am considering water, that is the system, and surrounding means environment outside the system. Then what is the example of this system? Flask, balloon, water, steam that was heated. See here, inside system together means this flask. Inside the flask we can consider the system. Then this balloon is there, water is there. Once the water is boiled, then it will be start converting into a steam. Then here water, steam, this balloon, then this round bottom flask, everything it will be converted into, we can consider as a system. Then what is the system boundary? This round bottom flask, you can see, no, I draw the boundary, that is the system boundary. Then what is mean by surrounding? Environment outside the system. Why I am explaining this one in detail means they will get confused between the system, surrounding and also boundary. Steam does work on the balloon. The steam internal energy has increased. Once the water start boiling, it will convert it into a steam. Then this steam, it will go inside the balloon. Then the balloon, it will blow. Then you can come to know the water is started converting into a steam. This it will look like a simple example, but we have to consider only the simple example when we will study in detail. Correct? Yes. Next one, what is mean by a system? In the system we are having the different types. Let us study in detail. Pooja Patil. Pooja, better you call, then you inform them why you not got the first class link, because I told no, only I will generate the link, then I will not distribute the link. I will send to them Raman tutorial, no? I will send my link in my laptop. I will create my link, then I will send my link to them. They will distribute. If you're not getting the link, then if you are not getting anything, then you have to ask with them only. Understood now? Okay. Next one, system. We are having different types. Let us study in detail what is the different types of a system. A thermodynamic system is a specific portion of matter with a definite boundary which our attention is focused. A thermodynamic system is a specific portion of matter with a definite boundary which our attention is focused. What I explained same only. The boundary may be real or imaginary or fixed or deformable. Sometimes the boundary it may fix, sometimes we have to imagine. There are three types of system. Isolated system. Please, if you have any doubt, ask at the end, because with explanation I can't see the chat. Even if I started reading the chats, I will get diverted. What I am explaining, my thoughts, it will be not like a proper way. Okay. Chaitra, I told when I started the class only, I told no. Read my whatever the PDF notes, videos, everything. Only it will help up to 50%. Remaining 50%, you have to go through the website. Otherwise, if you get another books, 100% I can't sure no. Whatever the questions we are discussing in MCQ questions, maybe that type it will come. Not sure exactly that question it will come. That's why whatever I am explaining, that is enough. Whatever the theory I am explaining concept wise, that is enough for you. No issues. But how many questions, MCQ questions I am solving in the class, that is not enough. At the completion of one topic, at least I am covering now 30 to 40 MCQ question. That 30 to 40 is not enough. At least for one chapter you have to prepare with 200 to 250 MCQ questions. Lot of MCQ questions you will get in the internet only. Search, take like thermodynamics. Then properties of thermodynamics, you type in Google properties of thermodynamics MCQ questions, then you will get plenty of questions. No need to write the question. Start solving the question. First you first you listen my class. First you understand the concept, what I am explaining. Theory part wise it is good. What I am explaining, that is enough. But you have to solve more MCQ problems. When you will solve the problem, MCQ problems, then only you will come to know whether you are understood the concept or not. Okay, solve more and more MCQ problems. If you solved 100% accurate answer, then your confidence level, everything it will build. Then you will only come to know. If you start giving wrong answer, maybe you have to realize what I understood, that is wrong. Start reading once again. Start listen my class once again. Okay. Then start solving more MCQ problems. Then you will come to know whether you understood the concept or not. Okay. That's why every day you have to read. Start solving more MCQ problems. In Google you will get plenty of questions. I am not getting more time. I told no. At least I am explaining the concept like slow, because explanation you nowhere you will not get. Even notes you will not get properly. I am searching through all the net, then I am making a proper notes. Even I am explaining like slowly. At least you will understand the concept properly. Once you understood better, you can get the questions from different website. You are having so many website, so many different types of questions, problems you will get. Better start solving. Once I will complete the portions, if I have the time, I will solve more problems. Okay. Okay, now onwards, if you have any doubt, please ask questions after the explanation, because what will happen, especially in physics, when I am explaining my full concentration, it will be explaining that topic only. Once I will get distracted means once again my thought everything it will get miss. Correct, no? All our teachers, you may understand properly. Explaining science is not that much easy, no? Explaining like a language it will be easy, like a story, but explaining like science topic we need more concentration. That's why I am asking. Don't mind, don't take it wrong way. Okay, next one, closed system. We are having different types. Isolated system. Listen here, an isolated system cannot exchange both energy and mass with its surroundings. The universe is considered as an isolated system. Consider this flask example. Consider here, neither energy nor mass it will enter into the system because this system is closed. Even flask also, after 10 hours, 12 hours, even if you put hot coffee or hot water also, later it will get cooled. That depends upon the quality of the flask, everything. Don't ask in that way. Okay, you have to remember here, isolated system means here only life example I given here, but isolated system means it will not either exchange the energy, it will not either exchange the mass with surroundings. It will not at all happen. The universe is considered as an isolated system. Best example is universe. Then that closed isolated system over, what is meant by closed system? Across the boundary of the closed system, the transfer of energy takes place, but the transfer of mass it will not takes place. Here you can observe the transfer of energy it will takes place, but there is no transfer of mass. Mass it will not get transfer. I will write here, maybe here you can't see. The energy, you can observe the energy it will get transfer. That transfer of mass it will not takes place in the case of a closed system. Consider here you are having the boiled water or any hot liquid you have, then this is closed with some rubber cork. Then here after some time, keep this one for 10 hours or 20 hours. Then after 10 hours, even after 5 hours also, if you touch this flask, you can feel that hotness it will lose. Okay, then here you can observe, yes Isha, that's why I wrote here. Okay, I will not write here, I will write here. Then here you can observe the transformation of energy it takes place. Either the transformation of heat also you can consider. The transformation of heat it will takes place, but the quantity of liquid it will not change. The quantity of liquid, maybe the quantity of mass it will not change. Before also maybe this is 200 ml you consider, then after 10 hours also it will be 200 ml only, but before it will be hot, after 10 hours maybe it will become cool, maybe temperature it will become decrease. Okay, understood everyone? Listen, isolated means there is no transformation of energy, then there is no transformation of mass it will takes place. In closed system, only the transformation of energy or heat it will takes place. There is no transformation of mass, transfer of mass. Next one, what is meant by open system? Name itself is indicating in an open system, the mass and energy both may be transferred between the system and the surrounding. Both here you can observe, even mass also it will get transferred properly, even energy also. What is meant by mass means quantity, how much kg or how many grams, that we will consider mass. No, energy or heat both also they will get exchange. Okay, even they can enter, even they can leave, open system also. That same hot water only, otherwise consider any consider hot water, maybe if it is reached boiling temperature it will be very hot. Leave the quantity of the level of the water also it will get decreased. Before if it is in this level, after maybe 5 hours 6 hour maybe little you can observe there will be a little decrease in the level of the water. Understood everyone what is mean by isolated system, closed system and also open system. Here I included one more. Surrounding means everything outside the system that has the direct influence on the behavior of the system is known as the surrounding. Surrounding everything, environment. If you are doing any experiment, even the temperature also it will play an important role. Everything, our surrounding environment, everything it will get matter. Then here I make it as a column for you. It will be easy to revise. Isolated, it will not transfer even mass, work, heat. No. Open system, it will transfer only mass and work. All the three it will transfer. In the closed system, there is no flow of mass. It will happen here. Only you can observe heat and work. Remember, okay. Then next, this one also very important. What is meant by thermodynamic process? 1 minute. I will drink water. Next one. Thermodynamic process. A system undergo a thermodynamic process where there is some energetic change with the system that is associated with change in pressure, temperature and also pressure, volume and also internal energy. See here, already I told when I am explaining thermodynamic process how they will get affected means they will get affected even with our environment. There will be a change in pressure, volume and also internal energy means if you consider any object, that object it has its own energy, internal energy. Then there are 4 types of thermodynamic process. First one is adiabatic, isochoric process, isobaric process, isothermal process. Let us study one by one in detail. This piston experiment I think everyone you know. A piston is a moving disc. Always if I use the word remember, piston means the arrangement of the device it will be like this. That is the moving disc enclosed in a cylinder. This is the cylinder, okay. Then here inside the cylinder you are having one movable disc, okay. That one we will call it as a piston. Even you will get the handle here also for pushing and expanding. You can observe this one. Then piston is a moving disc enclosed in a cylinder which is made up of gas tight by piston rings. It is made up of a gas tight means here if you closed with this piston ring, then here from the environment now even gas it is not able to enter into the system. It is like fully locked 100%. Even the gas it can't enter into the system. Then here the disc move inside the cylinder as the liquid or gas inside the cylinder expands or contract. You can observe the movement of this piston depends upon the how the gas whether it will expand or it will contract. A piston aids in the transformation of heat energy into mechanical work and vice versa. Then what is the use of this piston? It will help the transformation of heat energy to mechanical energy. To do some work we will use this piston. This one you can observe in the heat engine everywhere also. That even this thermodynamic last class I will explain in detail what is the use of heat engine, petrol engine, diesel engine, everything I will explain in that class. Detailedly I will explain what are the process it will happen in different types of engine. One particular topic is there, heat engine. Here only I am giving brief introduction about the piston. Here you are having once you provided the heat to a particular system, what will happen? It will absorb the energy, then it will get expand. That expansion only you can see here. Before this is the expansion. Once it absorb the heat, this much, the same system it will get expand. Why we will use thermodynamics, why we will use the word system means that system, whatever the changes, it will happen in that matter only, whether it may be solid, liquid, maybe different types of matter. All together we will consider as a system. Don't get confused. Why always I will use the word system. System means any matter, anything you can consider, anything you can imagine. Okay. Then here it will be constant for some time. Then once you started cooling, then that system it will get compressed. The heat it will come out. Okay. Once it will start losing the heat, what will happen? It will start compressing. And after compression it will come to its original state. What is the level of the system, what is the state of the system, come to its original state. When here you can observe, when the initial state, final state, if both they are same, then that process we will call it as a reversible process. That also in detail I will explain what is meant by reversible, irreversible. Here what you have to remember, when expansion, at what time the expansion it will happen, once any system, once it will gains the energy. Okay, once gain energy, you have to remember this one, once gains energy, then you can observe the expansion of the system it will takes place. One, it will lose the energy, then compression it will takes place, remember. Okay, then next one in detail I will explain. You are having 4 different types of process now. With example I will explain. Next one, adiabatic process, a process which no heat transfer are out of the system. Adiabatic, there is no transfer of heat it will happen. That process we will call it as a adiabatic process. I will explain with example, don't worry. It is a process where there is a gas compression and heat is generated. One of the simplest example would be the release of air from a pneumatic tire. You can observe tire wherever we will use, even bus, car, everywhere we will use. Here that one only we will call it as a pneumatic tire. See, releasing of air from the tire. Here you can observe there is no transfer of heat. Heat it will not at all takes place. Only you can observe the gas compression. The gas it will get compressed no when it is released. Here you can observe compression. When you will see here you can observe the compression. Assume this is the tire. Okay, this tire, if it is make any hole, then this tire, from this tire the gas it will come out, then you will feel the tire it will get compressed. That is the best example of an adiabatic process. Still I given more example, then you will get understand more easily. Then adiabatic efficiency is applied to device such as nozzles, compressors, turbines. One of the good appliances of the adiabatic process. This process you can observe in turbines also, nozzles, compressor, where we will use the compressor, compressing the gas. We will in all the types we will see the adiabatic changes only. Then a quantum harmonic oscillation is also an example of a adiabatic process. In all these cases there is no exchange of heat, only the compression of gas or compression it will takes place. Then here one more simple daily what we will use the example, when we put the ice into the ice box, no heat goes out, no heat comes in, correct no? In the freezer also you can observe, you are having the ice box. In the ice box assume that is fully locked. Okay, then here there is no transformation of heat it will take place. Heat neither it will enter nor it will leave. Therefore the ice box, inside the ice box the ice it will be, if you keep that one for 15 days 1 month also, you can store even years together, it will be in the solid state only. Means in the simple word you can remember, adiabatic process means there is no change in the heat, otherwise there is no transformation of heat, only the compression it will takes place in the adiabatic process. One more example here, adiabatic process, no heat exchange between a system and surrounding, there is no heat, it will not at all get exchange. And here you can observe the adiabatic compression, there will be the increase in pressure, increase in temperature, it will be takes place in the case of a compression here. In expansion, pressure also decreases, temperature also decreases. This one is very important. Compression, the change in pressure and temperature, it will be more. In expansion, pressure and temperature, it will get decreased. If you have any doubt what I am explaining, based on this topic you can ask the doubt. If you want to talk general or about the HSTR subject wise, you can talk me, you can ask the question at the end. But when I am explaining the concept, if you have doubt particularly in this concept, clear your doubt at this time only. Understood everyone? Adiabatic? Yes. No one is asking the doubt, means everyone you understood, I will feel. Then I will move to the next one. Okay. Then next one, what is meant by isochoric process? A process where no change in volume occurs, the system does no work. There is no change in the volume. Okay. Then there is no change in the volume. Then work done also it will be 0. You can consider isochoric. Isochoric, remember, volume, it will, there is no change in the volume, otherwise volume is constant, you can consider. A good example of an isochoric process is ideal Otto cycle. That is the name of the cycle. Don't ask what is mean by Otto cycle, ma'am. That is the name they are given, the scientists they are given. The ideal Otto cycle. In this we, when the gasoline air pressure is burned, this is the ideal Otto cycle. The setup it will be like this. Then here you can observe the gas is there, and also to measure the gas we have the, this instrument is there, it will measure the pressure of the gas P1 P2. Pressure it will be different here, pressure is different, okay, in the isochoric, but volume is constant or volume is same, you can consider, even constant also you can consider. And also here inside the gas contains what, it is a mixture of gasoline air mixture. Here in this cylinder we are considering the gasoline air mixture is burnt in car. This you can observe in the car. Here when you provide the fire, what will happen, this is a mixture of gasoline air mixture, then it will start burning in a car engine. There is an increase in the temperature and pressure of the gas inside the engine. Here you can observe the temperature also increases, pressure also increases. Meanwhile, the volume of the gas remains exactly the same. This one we will call it as a Otto cycle, where you can observe this one in the car engine, you can observe this setup. Okay. This one we will call it as a Otto cycle. Maybe exam they may ask. Then this Otto cycle, which type of gas we are using? Gasoline air mixture. Okay. Now you can observe nowadays even car also they are using cylinder. Correct, no? What we are using LPG cylinder, they will use that same cylinder? No, they will use the cylinder, but they will use the mixture of gasoline air mixture, maybe. Even though some other gases, I don't know exactly what gases they will use in the cylinder form. There you can observe this ideal Otto cycle, it will work. Not in petrol diesel engine, that working it will be different. I will explain that one in detail. But this one is the Otto cycle. Here we will use the mixture of gasoline air mixture. Then here the volume of this, it will be same, volume is same, remember, temperature, pressure it will be increases. That is the meaning of isochoric process. Remember, isochoric means the volume of the gas it will be remain constant, Even temperature, pressure also increases once you provide the fire. Once the car it will started running, then both the mixture they will get interacted, then it will lead to increase in temperature and pressure. Understood everyone? The next one, very easy one, easy example. Even how I included one example means scientifically I included one example. Another one, daily life what we will use. Isochoric, remember an example of nearly isochoric process is pressure cooker. This one every day we will use the cooker, no, when we will cook the food. When sealed closed, the volume inside cannot change. So when heat is added, both pressure and temperature increases. You can observe the volume, whatever the food you are cooking, the volume it will be same. It will be constant. Only you can increase. You can observe there will be a increase in temperature and pressure. Understood? That is a daily example where we are using every day. Then next one, what is meant by isobaric process? A process in which no change in pressure occur. Isobaric means pressure it will be constant. Where you will see this one, an example of the isobaric process include the boiling of water to steam and freezing of water to ice. Boiling of water to steam, and next example, freezing of water to ice. Here pressure it will be constant. You can observe here, when water is started changing to steam, then liquid form of water it will be converted into gaseous form. Then here in the liquid, the particles, at least you can see the small gap between the particles, but when it will come to gaseous, you can see the particle gap it will be more compared to this liquid form. Correct now? You can observe the change, but there is no change in the pressure. Pressure it will be constant. Then freezing of water into ice. Here also you can observe the liquid is changes to ice means solid. Here you can observe the change in the distance between the particles, heights. The particles they will be very close to each other, but there is no change in the pressure. Okay, then a gas either expand or contract to maintain constant pressure, hence the net amount of work is done by the system or on the system. Here the system it will do the work, but pressure it will be constant. Here consider this piston same. See here, when you provide the energy, what will happen? It will get the masses maintain constant pressure in the cylinder. Mass it will be constant. Here the volume it will be decreases, the volume it will be increases, but in both the case pressure it will be constant. Remember that one. Next, isothermal. This is the very easy one. In thermodynamic, an isothermal process is a type of thermodynamic process when the temperature of the system remains constant or zero. Here temperature is constant. Remember the word. Okay. Here also isothermal process, isothermal expansion, isothermal compression. Here temperature is the same. Even you can observe isothermal expansion also, isothermal compression also. When you provide the heat, this system it will absorb the energy, it will get expand. Once you decrease the temperature or decrease the energy, then it will start compressing. That one we will call it as a isothermal compression. Let us study with the example here. Change in state, phase changes of different liquids through the process of melting, evaporation, or the example of isothermal process. See, melting of any solid, anything you consider, then evaporation, melting, evaporation, everything is an example of an isothermal process. One of the example of industrial application of the isothermal process is Carnot engine. In this engine, some part of the cycle are carried out isothermally. Maybe Where you will study in this one Carnot engine? Maybe I will explain in but it is there in your syllabus. I don't know where completely we will study this one. In the Carnot engine cycle also we will study in detail two times isothermal expansion it will happen, two types isothermal compression it will happen. But this one it will need complete explanation of Carnot engine. It need 15 to 20 minutes, but it is there, I think it is there in detail in your syllabus. When it will come, I will explain. Here only the example you remember. Next one, a refrigerator works isothermally. A set of changes takes place in the mechanism of a refrigerator, but the temperature inside remains constant. Yes, the refrigerator, what it will do, it will maintain the proper temperature. Here everyone, you have the fridge, no? In the fridge we will set the temperature, it will be remain constant. Here the temperature it will be constant, but heat energy is removed and transmitted into the surrounding environment. You can check even the refrigerator backside. If you touch, you will feel heat, then you will be shocked. Refrigerator is nothing but it will make the food to cool, otherwise it will provide the food to spoil. How it will do? Because once you will keep the food inside the freezer, what will happen, it will decrease the, otherwise it will decrease the temperature of a particular food. If the food at a lower temperature, then there is no fermentation, there is no spoiling of food, it will not takes place at the lowest temperature. If you keep the food outside, then outside environment the temperature it will be more, that's why the food it will get spoiled. But here inside the freezer, working of the refrigerator also it is there in detail here, that I will explain. Okay, then here you have to remember, in the refrigerator there is transformation of heat energy it will takes place, but temperature it will be constant. Another example of isothermal process is the heat pump. Heat is either removed from the house or dumped outside. The heat is brought inside the house from outside, warm the house. In either case, the goal is to keep the house at the desired temperature of setting. Here we will use the AC. Why we will use the AC? To make our room cool. In some countries, if the temperature is -degree, then they will use that heater they will use. Then how the heater it will work? Whatever the temperature inside the room, it will be less, no? Then to increase the temperature, they will use the heater. Whatever the heater, otherwise AC, everything, how they will work? They will transform the heat, otherwise they will transfer the heat from higher temperature to cooler temperature, high temperature to lower temperature, they will transfer the heat. Then thermodynamic cycle, still it is there, more it is there, it is not completing only. Okay, are you feeling bored? Otherwise shall I continue another 15 minutes? Are you feeling bored? Are you feeling tired? Even I am feeling tired. Okay, listen here. Thermodynamic cycle is a process or a combination of process conducted such that initial and final status of the system are the same. A thermodynamic cycle is also known as a cyclic operation or a cyclic process. Cycle means here that Carnot cycle only we told, no? Cycle is nothing but a cyclic. The starting point, ending point it will be same, but here we will see the different changes in a full cycle. That one only we will call it as a thermodynamic cycle is a process or a combination of process conducted such that initial and final state of the system are the same. Initial and final they will be same. Cyclic operation or cyclic process. I will explain in Carnot cycle where it will come, no? I will explain that one. Shall I stop? Shall I continue? 10 more minutes. If I continue 10 more minutes, at least I can. Okay. Only 3-4 slides are left. Okay, I will continue now only. At least another fresh thermodynamics laws I can complete in next class now. Naziba, that I will answer at the end of the class. Okay, I will explain this 3-4 slides are there. Don't worry, I will answer that one. Next one, thermodynamic process properties. Thermodynamic properties are defined as characteristic features of a system capable of specifying the system state. Thermodynamic properties may be extensive or is intensive. What is mean by intensive property? What is mean by extensive property? Intensive property or the properties do not depend upon the quantity of matter. Quantity of matter means how much kg, otherwise how many ml. It will be not depend upon the quantity of matter. It will depend upon the pressure, temperature. That one we will call it as a intensive property. Always remember, intensive property, it will not depend upon the quantity of matter. It will be depend upon the pressure and temperature of a particular system. In case of an extensive property, their value depend upon the mass of the system, volume, energy, enthalpy or extensive property. Okay, always remember, intensive property means pressure, temperature. It not depend upon the quantity of matter. Extensive, it will depend upon the quantity of matter, like mass, volume, energy, enthalpy. I will explain what is meant by enthalpy in the next slide only. Understood? Intensive property, remember temperature, there will be change in temperature, pressure. Extensive means there will be change in mass, volume, energy and also enthalpy. I will explain what is meant by enthalpy. Okay. Next, enthalpy is the measurement of energy in a thermodynamic system. The quantity of enthalpy equal to total heat content of a system, equivalent to the system internal energy plus the product of the volume and also pressure. This H enthalpy we will indicate it by H. H, it will be equal to internal energy plus product of pressure and volume of that particular system. What is mean by internal energy means, if you consider any system, how much the total amount of energy that content the whole bulk system, already I use the word bulk now, how much the amount, otherwise the quantity of heat or energy it has the system, that one only we will call it as a internal energy. Then enthalpy is the sum of internal energy and the product of pressure and volume of that particular system. You have to remember this formula, then you will come to know what is meant by enthalpy. Understood? Mathematically, enthalpy is equal to the sum of the internal energy E plus product of volume and pressure of the system. Remember that one. Okay, in the real life, what is the application of enthalpy change? When we will see the, when we will learn anything, if we correlate with the real life example, then only we will come to know. Okay, the amount of freon, what is mean by freon? Listen here, I included here. Freon is a non-combustible gas that is used in refrigerant in air conditioning appliances. Where we will use this word, where we will use this freon, that is a type of gas, non-combustible gas. Combustible gas, oxygen is the combustible gas, correct? No, because it will help the, it will help for combustion, correct? No, to catch fire normally we need oxygen, but this freon, it will not help to burn something, otherwise it will not help for combustion. Only that is a non-combustible gas that is used in the refrigerator. Even in AC also we will use this one. Then this freon undergoes an evaporation process over and over again to help produce cool air that be circulated throughout the AC system. Even refrigerator, what is the use of this freon means, it will it will undergo evaporation. See, even you will feel those we will use, girls we will use that nail polish remover, no? If you apply nail polish remover on your nail it will feel like cool. Why it will get you will feel cool means that nail polish remover immediately it will get evaporated. When anything if it is get evaporated, what will happen? Heat it will release. Once the heat it will release, what will happen? It will cool the temperature. Understood? That is the use of this freon. Maybe in the exam they will use, they may ask in the refrigerator, otherwise air conditioner, what is the use of this freon? What is the, how it will work? It is a non-combustible gas, then it will be continuously evaporating. When it will start evaporating, it will make the surrounding to cool. Acetone. Nail polish remover is acetone only. Next. Then more. Okay. This is one of the great example of enthalpy change. Another great example of enthalpy change is hand warmer. Here hand warmers are there. What they will do? They also contain some chemicals. If you hold that hand warmers in your hand, this cold countries they will use this one. Even their hand is like a below zero temperature means you imagine what is their body temperature. Then someone they will get even die also. Even the lower temperature we can't live, no. Even our blood also it will start clotting. To avoid, we will use the hand warmers. As soon as you shake the heat pack, your hands become warmer. Then here you can observe there will be a transfer of heat. It will your hand it will absorb the heat, like that it will help. Then here understood everyone what is mean by enthalpy change. Enthalpy change means always remember there will be a change in internal energy. Sometime you will absorb the heat, sometime it will make the environment to cool. Like a refrigerator freon, it will make the environment to cool. Then here hand warmers, it will absorb the heat, then your body it will absorb the heat produced by this hand warmer. Then enthalpy means always remember there will be a change in the heat. The next one, okay, that one only I included here. Later you read what that hand warmer it is made up of, what I given, that they will not ask in the exam, but for your information I given. Then what is mean by entropy? One of the important, when we will study thermodynamic, enthalpy is very important, entropy is very important. Entropy is the thermodynamic quantity whose value depends upon the physical state condition of a system. In other words, it is a thermodynamic function used to measure the disorderness or randomness or disorder. This definition is very important. Entropy means the measure of randomness or disorder. Disorder means don't get like a disease. How the scattering, otherwise how the particles, how they will be scattered, how they will be arranged, how randomly they will get arranged. That is nothing but entropy. For example, entropy of a solid where the particles are not free to move is less than entropy of a gas where the particles will fill the container. Assume in the solid how the particles they will be very close to each other. In this case entropy it will be almost, it will be less. But when you consider the gas, all the particles they are very randomly arranged, therefore entropy it will be more. Therefore entropy is nothing but the measurement of randomness or how much it will be disorder. Next example of entropy. Entropy is a measure of the energy dispersal in the system. We see evidence that universe tends towards highest entropy many places in our lives. A campfire is an example of entropy. Why will campfire is nothing but it will produce the heat. randomness, correct? No, then here you can observe the heat, it will get spread randomly, campfire. Then ice, it will start melting. Then salt, sugar, it will get dissolved, that is also best example of an entropy. Then making popcorn and boiling water for a tea or process with the increasing entropy in your kitchen. Popcorn, how, when you are preparing the popcorn, you can observe the popcorn, they will be jumping. Then disorderness, it will be increases, randomness, it will be increases. When you started cooking, preparing tea, you can observe once the tea, once it will reach the boiling point, then you can see the bubbles, that is nothing but a randomness, correct? No, one more best example of an entropy is melting of ice, makes a perfect example of entropy. As ice, the individual molecules are fixed and order. Ice melts, the molecules become free to move, therefore moving, becoming disorder. As the water is then heated to become gas, the molecules are then free to move independently through the space. What I explained, conversion of ice into liquid or liquid into a steam, then the here the disorder, it will be increases. This also best example of an entropy. Always you have to remember the arrangement of particles, very close ice, liquid at least little far, in steam you can observe they will be very far, randomness, disorder, it will be increases. This also a very good example of an entropy. Understood everyone? This one it took more time, almost more than 1 hour 45 minutes. Yes, someone. Naziba, if you not get any old lesson notes, everything PDF format, better you have to call Raman tutorial, Chaya ma'am or sir. Then you have to inform them. Then they will send maybe classroom, they made one app. Then that class app, everything they will give. Then you will get the information. Clear your doubt? Naziba, clear? Regarding your no Renuka Nagabhushan, next class at least I need half an hour break, okay? Sir told another sir is taking class now, like Rakesh sir, maybe he will not take class today, I don't know. Okay, maybe after half an hour I will take the class, okay? 7:15 I will take 1 hour maths class, because timing of next class it will be 7:15, I am telling, no, 7:15, because I am feeling little tired, at least I need half an hour break. Continuously we can't talk, no? 7:15, 7:15 to 8:15 I will take today only 1 hour. I am planning to take maths 2 hour, but per at one day I can't take 4 hours continuously. I can't talk. Even 2 hours is the maximum. Teaching in school is different. Teaching in online is different. Only one way continuously I have to talk. No, see, more than 1 hour for 15 minutes continuously I am only talking. That's why we will get more tired. That's why only 1 hour I will take maths. If possible, tomorrow if I get the time, I will take one more class like 4 to 5 I am planning. Okay, that's why see the notification after 4 to 5 o'clock. Okay, we will meet at 7:15. At least half an hour break I will get. Polynomial, don't miss the class. In polynomial, we will I will solve multiple choice questions. Okay. Okay. Bye everyone. We will meet at 7:15. Okay. Only 1 hour I will take. We will see. Yes. If you have any doubt, Naziba, your doubt better. Your everything. Talk with ma'am only. They will only clear all your doubt. Everything. Okay, bye. We will meet again.